Before we even get started with any work, we're gonna get to know these terms and definitions so that we can actually pass with good marks. First of all, moles. Think of the term a dozen. It's not a number. We know that a dozen represents the number 12. A dime represents the number 10. If I have a dozen eggs, I have 12 eggs. A mole in chemistry, it's the same concept. The only difference is that a mole represents a much larger number, and that number is also known as Avogadro's number. That number is 6.02 times 10 to the 23rd power. That's like a lot of zeros, and the reason that number is so big is because moles, and that number specifically, is used to deal with a lot of objects, like a lot of particles, a lot of atoms. There's so many of them, and they're so small, it's just easier to use that larger number. So a mole is just a unit of like measurement. It's just a unit used to refer to this very, very large number. Moving on from moles, molar mass. Pull out your periodic table. At the bottom, it'll have the element's mass listed. That mass is called the average atomic mass. If you studied isotopes already, basically different variants of those elements, their masses are taken, average, and that gives you the number that you'll find on the periodic table. The average atomic mass of an element is equal to its molar mass. So I'll show you a problem where we're going to go into this in more detail. So there's a quick explanation of moles, molar masses, Avogadro's number. Stick around for the next video where we're going to do some problems involving molar masses and those formulas that you see on the screen. Bye!